Check, check. Check, check, check. Check, check, check. Is it working? Yeah, it's working.
What is the maximum?
Yeah, yeah. That was not working.
I put your sound max. You have to. On here. Now there is no.
Hi.
IPCC Chair, it's a pleasure to say a few words at the start of this joint FAO IPCC event on agrifood systems.
Very high.
Scientific knowledge is the foundation for understanding climate change, its impacts, feasible responses. It provides the evidence to identify risks, assess viable solutions, and understand who is most affected, helping governments to shape effective and fair climate responses. Now, FAO and IPCC have a solid history of collaboration. I recall the co-sponsored expert meeting on change, managers and food security held in Rome in 2017 during the 6th assessment cycle. And this was actually a prelude to deeper collaboration during the preparation of the IPCC special report on climate change and land. As IPCC chair, it's a pleasure to say, as IPCC
We're trying because we.
Eva was one of the first ones saying, congratulations. I'm like, what? Oh, yeah. Apologies, I was gender is driving.
So we start with the. Like the video, oh, yes. Yes. Yeah.
Okay. Climate plus the explosion. We're going to do the white paper. Then.
We can't start there. We're waiting. I mean, we can wait. What?
I have to be.
Okay. So I start? So I started. All right. I can start? Okay. Good morning. Good morning, everybody. Nice to see you all here. My name is Kaveh Zahidi. I'm the Director of the Office of Climate Change, Biodiversity and Environment at FAO, the Food and Agriculture Organization of the UN. Today, we're focusing on how climate science, of course we are, we're in the climate science pavilion, right? We're focusing on how climate science can guide the transformation of agri-food systems. Of course, we need science to identify the pathways, the solutions, especially from agriculture and food systems. And because of that, we've brought together some very eminent panelists today from the IPCC process, specialists from WMO, and of course, specialists from the Food and Agriculture Organization of the UN as well. And we're going to talk to you about interactions between agriculture, food systems, and climate change. As the IPCC begins work on this 7th reporting cycle, it's quite important for us to, in a way, take stock of where we are on the agriculture piece and what more needs to be done to close any scientific gaps as we head into the new cycle. And so the perfect introduction for our event today is the opening remarks that will come from the IPCC, and then we're going to have 3 presentations about 4 new reports on science, and then a panel discussion. And we'll try to rush through as quickly as possible because I know everybody has multiple engagements. So with that said, and without further ado, it's my pleasure to invite our opening speaker, who's Professor Jim Skee. Doesn't need an introduction to anybody in this pavilion for sure, but chair of the Intergovernmental Panel on Climate Change. And Professor Skee has sent us this video message to kickstart our conversation today.
As IPCC chair, it's a pleasure to say a few words at the start of this joint. Scientific knowledge is the foundation for understanding climate change, its impacts, and feasible responses.
It was working
It
a moment
provides
ago.
the evidence to identify
We were listening to it
risks,
before the session started, right?
and understand what's most affected. Governments shape effective and fair climate responsibilities. I got that wrong. I'm going to start again. Okay, you all.
Hold on, it is important we have these words.
That's right. If it's more.
As IPCC chair, it's a pleasure to say a few words at the start of this joint FAO IPCC event on agri-food systems. Scientific knowledge is the foundation for understanding climate change, its impacts, and feasible responses. It provides the evidence to identify risks, assess viable solutions, and understand who is most affected, helping governments to shape effective and fair climate responses. Now, FAO and IPCC have a solid history of collaboration. I recall the co-sponsored expert meeting on climate change, land use and food security held in Rome in 2017 during the 6th assessment cycle. And this was actually a prelude to deeper collaboration during the preparation of the IPCC special report on climate change and land, which I had the honour of co-leading in my role as co-chair of IPCC Working Group 3. FAO were a great help through participation in pre-scoping activities and through Francesco Tubiello's participation as lead author in the food security chapter and as drafting author for the summary for policymakers. Now, I was actually rather proud of the land report, which broke new ground in addressing the food system as a whole. As one of the sectors most exposed to the impacts of climate change, the agri-food system faces an urgent challenge in managing the risks posed by extreme weather. The growing threat from both droughts and extreme heat events tests the limit of traditional risk management and demands a new level of resilience to safeguard agricultural livelihoods and food supplies. The land report and the 6th assessment report noted clear and growing evidence that climate change is already altering crop yields, livestock productivity, water availability, and ecosystem functioning. And these impacts directly affect food security, livelihoods, nutrition, and biodiversity. Strengthening resilience in agri-food systems is therefore essential for safeguarding the well-being of people, economies, and ecosystems. Now, turning to the IPCC 7th cycle, food systems continue to feature in the scoped reports. Working Group 3 on mitigation continues to have a chapter on agriculture, forestry, and other land uses, which accounts for roughly 22% of global greenhouse gas emissions and all current carbon dioxide removals. This chapter will cover mitigation measures and potentials in the context of sustainable development and global warming levels, and the use of data on emission factors, forest and soil parameters, and livestock production systems from underrepresented regions. The Working Group 2 report on impacts, adaptation, and vulnerability has a chapter devoted to agriculture, food, forestry, fibre, and fisheries, which will cover adaptation in food supply chains and agricultural production, taking into account food and nutritional security, affordability, dietary diversity, and sustainability. And in addition, the interactive atlas being co-developed by Working Groups 1 and 2 will include more geographically specific climate projections than was the case in the 6th cycle, and this should have great relevance for actors along the food chain. I note also that the methodology report on carbon dioxide removal technologies will develop default factors for soil organic carbon estimates in respect of croplands and grasslands. And finally, it's the shared intention of the working group co-chairs, the vice chairs and myself that the 7th cycle report should result in findings that are actionable at all levels. And this is reflected in the title of this pavilion, indeed in the title of this session on transforming agri-food systems through climate science. And I'm pleased to say that FAO and IPCC are working together on another co-sponsored expert meeting, exploring the interactions between agriculture, food systems, food security, and climate change. And this has the support of all 3 working groups, and I should say myself as the IPCC chair. So in summary, the topics covered in this session are highly relevant for the IPCC's 7th cycle. I look forward to the session and continued collaboration with FAO. Thank you for your attention.
Thank you so much to Professor Jim Skee for sending us that message and underlining again how important this interaction is between agriculture and climate change and the plans already afoot for the next cycle to incorporate this analysis. We're going to dig a little bit deeper into some of the issues that, in fact, the 7th cycle can pick up on through 3 presentations that are going to follow immediately now. As I call you, maybe you just come and join us here up on the podium on the stage as well. We have first Dr. Stefan Uhlenbrock, Director of Hydrology, Water and Cryosphere at the World Meteorological Organization, who's going to present to us not 1 but 2 reports. Please, Stefan, take your place. Martial Banu from FAO, Senior Natural Resources Officer, who will present to us an update on scientific findings on the interactions between agriculture, food systems, and climate change. And I hope we have online our colleague Francesco Tubiello, who Jim Skee just mentioned, who's going to speak about the latest FAO stat release of Agrifood Systems greenhouse gas emissions data, which I think reveal actually some interesting trends in where our sector finds itself. So to start us off on this conversation, Dr. Stefan, it's you who are going to talk about not 1 but 2 reports. I was instructed that I had to hold this up as one of the 2 reports that it's the main. No, it's not the main report. It's one of the 2 reports that you'll be speaking to, as well as the state of climate, of course, which is such a seminal part of our work. So over to you.
Thank you so much, Kadif. Can I have my slides? Actually, to confuse matters, I'm actually going to speak about 3 reports, but 2 I will just mention for the overall framing, and then focus on the heat aspects, extreme heat. You know, standing here at the COP climate conference, you know, I think that there's no news. I think this has been widely publicized already. This is the results, a key result from the latest Global State of Climate Report, which was just an update, which was published a bit more than a week ago. And you see here different temperature records averaged, and you can see that 2024 was the warmest year on record. We never observed such a warm year. You might remember almost every month there was yet another press release. Oh, it's again another temperature record in this month, fueled by a strong El Niño signal as well. 2025 is also on its way on becoming a very hot year. For the first 8 months, it's about 1.4 plus 42 plus minus 0.12 degree above the average, but it's still, don't be confused because it's lower than 1.5. It's still on track to become the 3rd warmest year on record, and we are really in the area of 1.5 above pre-industrial temperature records. Yeah, I think that this is clear. Can I have a clicker or who's manipulating the slides? You do this. Yes, please. Next one, please. Second report, just for the framing. we publish every year the State of Water Resources report, where we compile all the water resources data that we can get a hold of. And this is just one example of the precipitation in 2024. And what you see there is a precipitation anomaly. So we looked at 2024 precep compared with 30 years before. Yeah, and what you see here, there's particularly areas where it's very dry. Most of 2024 were characterized by an El Niño signal, so a large part of South America are significantly below average precipitation, as true for Southern Africa and other places. In the Sahel, it was relatively wet, you know, that's surprising. But, you know, the mean annual rainfall is of course super low here, but still significantly above average. So you see the variability. And what we also see, because we do this report every single year, that the water cycle dynamics become increasingly erratic. So somebody in the corridor discussion before, she just said, it's always too wet or too dry. That's true, because we increasingly see statistically, it is more and more either too wet or too dry. Actually, last year, when we look at the river basin, I don't have slides on that, only about 1/3 of the river basins globally behave normal. Behave normal meaning in the statistically normal period, as the way it's defined there. I skipped the details. That means 2/3 of the river basin are not behaving normal. They're either too wet or too dry, and we see this increasing. Maybe I leave it there. And now the main messages I was asked to present, and that is really linking to the extreme heat. And I really would like to acknowledge the extremely nice collaboration the FAO has together with the WMO in producing a report. I think it was just online now or last week or so, something like this. And you see here from the 2025 years, a number of key climate hazards, and the one circled in red are related to heat. Often we see so-called compound effects. So we have a relatively dry, abnormal low precipitation area. On top of that, a heat wave. And that is, of course, damaging for a number of reasons. And you see a few examples, often accompanied then with fire or with impacts on the crops and livestock and so on. Next slide, please. So therefore, if we look at extreme heat, and these are really results from this joint FAO WMO publication, you see here the impacts on different sectors, particularly on the agricultural sector, and it's obvious that extreme heat is damaging the crops, is impacting the livestock, is impacting the animals in general, not only livestock but the wild animals, if I may say so. Not sure if that is the correct term. Sorry for this. An impact on the farmers, etc. In total, it was estimated some 1.2 billion people that rely on agriculture are affected by extreme heat. Next slide, please. It has significant impact on the agricultural production. It can be as disastrous as no yield at all for a single farmer. For larger economies, it can easily impact 50% of the agricultural productivity, which is a multi-billion-dollar loss for the agricultural sector, which is dramatic for the farmers involved. It's billions of hours labor lost each year, destroyed by extreme heat. Also, I found an interesting statistic in the report that farm workers or agricultural workers are 35 times more likely to die from exposure to extreme heat than most of us. I assume most of us are not so much in the fields out there, but it is dramatic with the impact of extreme heat. Also, I think I mentioned before the compound effects. What we observe a lot is for instance, during very strong El Niño sickness or La Niña sickness, you have pronounced low precipitation regions around the world. During El Niña, large parts of South America, for instance. La Niña, it's other parts of South America. So it depends regionally. I don't want to go into details. But on top of that, then is the likelihood for extreme fires is increasing. The likelihood of heat waves is also increasing. And then this elevates further. In this report, which I highly recommend for you to have a look at, there's also a number of case studies about this, and I found a very illustrative one, for instance, for Morocco. Next slide, please. But also because we are in Brazil, you see here during the drought 23-24, again, largely characterized by the El Niño signal. It had a significant impact on the agricultural sector of Brazil. 10% of the reduction in soy harvest, but also worst wildfires on records. So it really, these things are impacting significantly, not only talking about other ecosystem services. And last slide, please, if I may. There's hope. The advantages, because of the good science, summarized in this report, contributed by researchers from universities, from the CGIAR and many others, there is adaptation options. For instance, through no tillage or through covering the soil, for isolating the soil against extreme heat, for preventing the too quick dry out of the soil. There's different agricultural techniques that can really help to mitigate the impact. There's also heat is for me as a hydrologist or working in hydrometeorological forecasting, it's relatively easy to predict, relatively. So compared to say exactly it's going to rain so much next month in this area, this is very difficult. In the next hours, yes, but for the next months, are very difficult. But heat is something which is a bit easier to forecast, if I say so. I'm not saying it is easy, but it is predictable. So together with National Hydromet Services, together with the science and knowledge and the extension professionals that we have, there's hope to mitigate the effects of extreme heat if we are prepared, if we know what we do, and if we have the necessary resources to invest in this. Final statement. She wants me to go, huh? The adaptation is not enough. We can mitigate the impacts of it, but at the end, it's down to regulate climate change, to really avoid that as much as we can, to reduce the impacts. Thank you so much.
Thank you so much, Stefan. I think you've exemplified exactly what Jim Ski was talking about, right? We've got to bring. There are so many of these interactions that we have to now reveal better, right, in the next cycle, and then make them action-oriented. That's exactly where he finished. So thank you for that, and thank you for the collaboration on the extreme heat report. So let's jump immediately now to our next speaker, Martial Benoit, to talk about how we're closing that science gap as we head into the 7th cycle.
Okay, thank you, Kaveh. And I will try to be fast because I see a large audience. So just you can put already the next slide on the next one. So now just to inform that today we have released a new report. So Jim was mentioning that we were working together since 2017 on to anticipate you will see later, we'll announce the new expert meeting that we will organize together with IPCC, but we were working hardly already to already look at what is already available. The special report on land was back in 2019 with a cutoff date for science by 2018. So basically all the scientific paper for the last 8 years are basically for the moment not in any IPCC report. So the idea that we already had this year at FAO, in the Office of Climate Change, Biodiversity and Environment, was trying to put together 60 scientists from 26 countries. More than a third of them have been involved in the 6 assessment report or previous, or since then have already been selected by the IPCC to be coordinated lead author or lead author of the IPCC 7th cycle. And you see, we're trying to, so you have the QR code, it's online from today. Please have a look. I will navigate you really quickly because that report is, I'm sorry for that, Kaveh, it's a scientific report. So it's a science. So it's long because you have the different chapters, and scientists, they want to share all what they have. But it's really the best and the strongest science. And hopefully it's also simplified on our website. So next one, Liva, please. Okay, so you have here the key messages. So the 1.2 billion people that you already mentioned, Stefan, and it's good that we align with the same number. So, but you see basically the impact that, so I will not go further because you already mentioned that on the extreme heat side, but it's all climate change on the drift, the long-term drift, all the extreme events that are impacting in different way with the compounding effect, different productive systems. So we can move quickly to the next one. Okay. Afolu, why it's important? Jim mentioned 22%. So this is a production level. But if you look at all the value chain, the sector is responsible for more or less 1/3 of the greenhouse gas. And is not attracting 1/3 of the climate finance, for instance, to solve the situation. So we have a sector that is impacting a lot, but that is also impacted a lot by the climate change. And you see the number of, some number here, agriculture, 70% of fresh water. It gives you, and you were mentioning that map of where the dryness or the wetness have changed. So this has impact on that. So also irrigation, but also competition for water, for human use. So this is really important that we are able to navigate that. Liva, if you can go to the next one. Okay. It's important, but we really still have an untapped potential. There is a lot of potential in the agriculture sector. It's untapped for a lot of different reasons because it's a most complex sector to address, but we have no choice nowadays. If you look at IPCC scenario, none of the scenario can bring us to the 1.5 without the FAO out. So we have no choice. If we want to have the 1.5, we have to tackle the challenge of complexity. Next one. Here you have a summary of the 5 solutions. I will not navigate through those 5 solutions because it will be too long, but just if you type on your computer FAO.org, today this is a landing page of FAO where you have a story showing exactly all those 5 solutions that can be unfolded, a scale to really help us to first mitigate, but to build resilient system to minimize the loss and damages. So it's a continuum. On the FAO sector, the agriculture sector is the only one sector that can go to A to Z, from the mitigation, adaptation, and also trying to help us on minimizing the residual risk. So here you have the number. I will not navigate through that. The slide will be online on the recording after, and you have it on the FAO website. Next one. Okay, so this is a kind of a new information because it was not just updating the information, but since then there was a lot of new debate. And here I can focus also on someone, for instance, here, bioeconomy and circular practices. This is under that COP. We have seen already a lot of events mentioning bioeconomy, circular economy. So this is really one of the sector where science was basically not providing a lot of information 10 years ago. Now we have much more information, and we can already build on that to provide some advice. IPCC is not perspective, but IPCC is informative. And so this is what we need to have here. And you have also another one that is really important on aquatic. Aquaculture, it was a report released by FAO last year that was showing for the first time the protein from fish are mostly from aquaculture rather than catch. So this is really important, and there was really few information. So we try to start to synthesize, look, protein from fish, no, it's mostly from aquaculture. So we have really to understand what is happening here on what are the potential and how we turn those systems resilient because they are dominant now. So it's important that they're very resilient. Okay, here's some action. I guess most of you should know those different action or have perhaps here some information. So sustainable rice system, rice because it's also a lot is dependent of water. So we have to really manage well the water we have, but it's emit methane. Methane is a powerful greenhouse gas with a short life in the atmosphere. So any action we take today, we will see a result, not immediately, but in several years. On soil organic matter, this is the more we have, the best it is in soil, and no one will never go against that. We can debate on the way we do that, but we know that we have to put back the carbon that we release degrading all land back to the soil to increase the fertility on the water cycle. Livestock, another important one, and also mostly methane. Those two, the third and the first, in terms of methane, are already nowadays the first methane emitting sector, 42% of the methane emission worldwide. On FAO, we are producing a lot of data, and you will see them on the next presentation, so I will not extend here. Francesco will really navigate through that. Next one. That's it. Thank you. And please go read. It's long. Cave, you have to read the 150 pages or more, but you have also a summary for all of you to be able to navigate that.
Thank you, Marcel. No, it's long, but it's an important piece. But that's why we've done some communication around it to try to distill it into the actionables, as the chair of IPCC was talking about. But it is also an input document to the workshop next year. And I think if we could also invite our new vice chair of Substart to that workshop, that would be helpful. Where we try to make sure that we review that as a scientific community and make sure that we are inputting into the next cycle and closing some of those scientific gaps or the new areas that you mentioned that we found. So let's jump next to Francisco Tubiello. Francisco, I don't know whether you were online. The IPCC chair mentioned you specifically as a very helpful colleague and ally when looking at this issue of climate and agriculture in past cycles of IPCC. I know that you're joining us in the middle of the night, and it's hugely appreciated to give us a little bit more about the numbers that you produce every year, especially around greenhouse gas emissions from the agriculture sector, but some nuances that maybe you can share with us that come from this year's numbers in particular. So Francisco, without any further ado, over to you.
Thank you, Kaveh. Can you hear me and see me?
Very, very well.
Excellent. So I understand someone will show my presentation. Otherwise, I can do it from here.
Okay, could you upload them from your side?
Yes, I will.
Technical
Okay,
challenges on this
absolutely.
side.
Let me do that. Let me see if they come through. Please confirm.
Yes, if you could put it in slide mode.
Here we are. Okay, thank you, Kaveh. Good morning, afternoon to everyone. Very thankful for your invitation and happy to present the new data on agri-food system emissions from FAO. Sorry, I have the entire presentation here. Here we go. Before I present the data, I just wanted to provide a feeling for where these emissions come from and within what is the mandate for FAO to do this. As you know, from the statistics side of the organization, we provide global knowledge products in terms of data with global and regional and country coverage that relate to food and agriculture. The important detail here is that they have information by country over long time series in FAOstat and are based on data that are, for the most part, officially provided by countries to us through our international submission processes, data processes. We do this, as I mentioned, on the one side to provide a global knowledge product in areas where none existed before. For example, the greenhouse gas inventory for agriculture and LULUCF, which began to be produced about 10 years ago from FAO and led into our provision of data to the IPCC that Ski has so gracefully mentioned. But we also do this because we work hand in hand with our own member countries in trying to increase their capacity to produce their own information, and in this case, greenhouse gas inventories. And so we try to replicate what each country would do, in this case, use their activity data on agriculture and apply the related and relevant IPCC guidelines to estimate emissions at country level. And then by doing this country by country, we can have a global picture. So the result of this exercise is the provision and the update of these data sets every year. And you see the two most important that relate to emissions. The first one is the FAOstat emissions data from Agrifood Systems, which was just released a week ago ahead of the COP. It covers all data from 1990 to 2023, and I'll add a few more details about which data are in the data set in the next slides. Also, very importantly, within the Agri-Food Systems database, we also go into special storylines for each aspect of the agri-food system. And this year, our main focus was on forest emissions and removals because we were lucky to get the new data from the FRA 2025 cycle, the Forest Resources Assessment, which is a separate data collection exercise that lasts for 5 years. So data are published every 5 years, and we use them to estimate emissions afterwards. Now, what is some of the important information that comes out of these data sets? And so I'm going to provide some global highlights and then some country highlights on what the data say? Well, first and foremost, because the data cover every aspect of agri-food systems and every scale from country to global, we are able to provide a global storyline. And the global storyline is the one that has begun to be confirmed since the last 3 to 4 years, when both FAO and separately and independently the European Commission started to provide this comprehensive data that not only have information from agriculture and land use, but complement them with information for emissions on the supply chain. So the big storyline that is taken as a system, these emissions are around 16 billion tons of CO2. That means about a third of the total emissions that we put out as human society into the atmosphere. That's a big number, and that, of course, puts the focus and the onus on agri-food systems to be part of the transformation that will lead us to beat climate change. The second message is that the components of the agri-food systems emissions. So about half of these emissions come from agriculture. Coming from agriculture, these are mostly non-CO2 emissions, methane and N2O. These emissions have been growing modestly at about 1% per year, so they've increased over the last 2 decades by 17%. And then the other 2 parts of these agri-food systems have completely different stories. So the land part, and you see them here so the farm gate, the agricultural emissions were in yellow, the land part is in green. And you see these are important, are about less than 20% today, but are becoming increasingly less of a contributor to this pie, thankfully. That speaks to the successes of some of our activities in reducing mainly deforestation and ecosystem degradation. So they have decreased by about 6%. But the other important part of the story here, that they're mostly CO2 emissions, so they are an important focus of mitigation still today. The other part of the storyline, which we began highlighting a few years ago, and it comes through very strongly in the data in this new release, is the role that the emissions on the supply generated on the supply chain has. So they have now a weight of about 25% in the total pie, but they're growing very, very strongly at over 30%. These are emissions that come from energy use and use of fluoride gases in things like transport and food manufacturing, retail, household consumption. So the report highlights all these different components. It also shows, for example, and you see this in a separate brief that was published together by the Office of Climate Change and the Statistical Division, about the emission intensity of this pie, which also decreases very strongly by about 25% over time.
Francisco, can
Yes.
we rush you a little bit, because we might lose one or
Yes,
two of
yes.
we don't want to miss your slides.
Okay, I will. Thank you. So this slide is only to highlight that the granularity of the information that is in the database, and you see here the 3 colors that you've seen before, but with a lot more detail. So I'll just mention here that what you see is a highlight of the most important emissions per the 3 pillars of the agri-food systems. Livestock being, as we know, a very important component of emissions from the farm, deforestation leading the emissions from the land part, and then a pool of transport and household consumption and manufacturing of food in the supply chain. And you see also here the different degrees to which these things are increasing or decreasing. And just to mention here that there is an apparent decoupling between emissions from deforestation and livestock, which is to be further investigated, but providing very positive and encouraging outlook for the future. Now, in terms of country, what you see in the data is a detail by each country of interest. In this case, you see a top 10 list of the 10 top agricultural producers. So, of course, you see 2 things. One is the size of the emissions, of course, scale with the size of the country. But importantly, you see that the database is able to show you the different makeup of that agri-food systems emission country by country. And I'll just highlight two cases. China, on top here, you see it's one of the few countries that has emerged where the emissions on the supply chain is larger than the emissions on a FAO. And of course, this points to informing mitigation action in the future within an agri-food system total. In countries that are strong emerging economies, where instead land or still plays an important role in that pie. Finally, in terms of emission intensity, this is, if you will, a measure of how efficient or the inverse of the efficiency of emissions in a country. You see countries with, they're very highly efficient, so they produce less CO2 per dollar of value produced within the farm. And others that are less. The ones that have the least efficiency, of course, are those that are still expanding into natural ecosystems to achieve their production goals. And the last slide, and I close, this is, again, to go back to the focus that I mentioned in the beginning, so the detailed on the emissions from forest and forest conversion that emerged from the last FAO report, showing on the left the countries with the strongest forest sink on their remaining forest land, and on the right, the countries that are emitting through the loss of forest for agricultural activities. So with that, Kaveh, I conclude, because these highlights are the ones that I provided in the beginning of my presentation. Just highlighting that FAO data not only provide a good global knowledge for informing where agriculture stands currently, but also provide a useful tool for countries for support in their national greenhouse gas construction and information on their mitigation practices. Thank you.
Thank you so much, Francisco, and thank you so much for joining us, as I say, in the early hours and putting some of these pieces in front of us. And just to mention, because our colleagues at the ENB are going to do a little report on this session, that we will put into that the summary report that brings out some of the messaging from the data that you kindly presented to us today. So we'll make sure that you all have access to that. As I say, I think it's quite revealing, including on what he mentioned of how there is a tendency for more of the emissions now from pre and post production. That's a big difference when you're talking about actions. So if I could jump straight into our panel discussion and invite Lucy, Carol, and Therese to maybe join us up here on the stage.
In a second, I'll give you short clip.
So Dr. Lucy Njunguna, who is the IPCC lead author and technical expert under the UAE Belém work program for the Global Goals on Adaptation, and works at CGIAR, works with the Alliance of Biodiversity International and CIAT, where she develops tools and evidence to support countries in planning and monitoring a lot of their adaptation work. Very welcome. You are the perfect person to help us turn this into action on the ground. We also have Dr. Carol Franco, who is the vice chair of Substar, professor at Virginia Tech. She's from the Dominican Republic, obviously a very eminent participant at this gathering, and a high profile one. And we're going to start with you because we know that you have multiple commitments this morning. And then we have Dr. Ceres Jones, who's from the World Farmers Organization. It's so important to sort of see the view from the other side as well. Ceres is the co-focal point of the UNFCCC Farmers Constituency on behalf of WFO, who of course is a big partner of us, and does her research on farm GHG accounting at Cranfield University in the UK. So we're maintaining the science theme. You know, we have pure scientists, but we're very much action oriented. We have questions for you, but maybe Carol, I start with you, just changing it up a little bit. We've heard a lot about climate science, but how and is climate science, all of the new things that we're beginning to find, all of the gaps that we're trying to close, is it shaping national policies? Are you seeing it in NDCs, the national adaptation plans? And what does that mean in terms of the emissions and the resilience that we need from agriculture and food systems?
Thank you so much, Kaveh. That's a great question. In Dominican Republic, yes, we are including the climate science into our plans, into our policies, into our NDCs. I happen to be the lead consultant for our NDCs in Dominican Republic. And that was one of the main points that we had to make in the agriculture sector. How much do we know? What is the science behind it? And how can we make sure that the reductions that we are proposing, we're going to be able to achieve them? The same with national adaptation plans. We are doing risk assessments, vulnerability assessments, just to make in the agri-food system, just to make sure to know how can we adapt to climate change, to the droughts, to the floods that are happening in the country. What is the state of our agri-food systems in the country? And a lot of work is going into that. The same we are in our NDCs is we're going to start getting into what would be just transition, and one of them will be agriculture. Making sure that we incorporate that as we try to decrease emissions, and we make sure that vulnerable groups are not becoming more vulnerable because we are trying to decrease those emissions. So national adaptation plans is another one. All this is under the Ministry of Environment, which I am advisor for nature-based solutions of the ministry. So we work a lot on all these issues. That said, there is always, a time lag between all this information is out there and when you can incorporate it. And also, a lot of the finance that comes is not necessarily for data collection or for science. Is a lot for application, which is extremely important, but you also need to be able to collect the data, to include the science, to be able to have the studies up to date so you can include them. So those are things that we need to still work on. We are working in the country trying to do as much studies as possible. Universities are helping a lot. There's a network of universities working on it, and also NGOs do a lot of the work. All under the umbrella of the Ministry of Environment, but we still need support trying to make sure that those studies can be more localized and we can find ways and solutions, sustainable solutions to be able to decrease those emissions and adapt to climate change. Thank you. And I'm gonna run. Sorry, because I have to co-facilitate gender.
No problem.
But thank you so much, and I'm very happy to be here.
Thank you. Thank you so much, Carol. If you can pass that on. Thank you so much. And attending this side event means that you will be a part of this whole process as well. So thank you for joining. Lucy, we jump to you. I mean, in a way, we have to shorten that time lag that she just mentioned, right? Between having the science and actually making it applicable. But in some areas, we don't even have the science, right? There are still some science gaps that remain in terms of understanding the risks to agri-food systems, in terms of broadly climate and agriculture. How can Article 7, I have in my questions here, help address some of these gaps? I would go further. I would say we're just not seeing agriculture and food systems in much of the text of any process, including Article 7. How can we close that gap as well? Close the science gap and close the gap in terms of getting it understood and reflected in the negotiations. Over to you.
Okay, thank you and good morning, everyone. Thank you for inviting me to this session. It's always fantastic to sit in an all-women panel, so kudos for that. Yes, so I'm going to highlight maybe some of the gaps that we've seen, especially when we reflect on the AR6, because now as we start planning for AR7, so it's a reference to the 7 assessment cycle of the IPCC. And one of the key gaps, and it was actually one of the key messages coming out, if you look at the Working Group 2 report, is that while we're seeing stronger knowledge coming out in terms of documentation of what adaptation actions are happening. And if I can already reference what Stefan was mentioning during his presentation, that we can see already there are some adaptation options that have been documented to even respond to climate shocks such as heat. But one major gap that is still persistent is our understanding of how effective these solutions are to responding to climate shocks across different warming scenarios and also across different geographical scales. Because at the moment, and again, this was a key message, is that the current knowledge that we have is fragmented. And this is mainly because even if you go to assess how effective your adaptation practice and technology is, it's based on a single case study. So we don't have evidence synthesis of what is working across the different scales. And one of the reasons why this is happening, and it's a major area of work that is then connected to the AR7, is because the kind of methods that we're using to assess adaptation options, they are still not at par. Again, if you look at the chapter that was dealing with decision making, they found with strong confidence that a lot of the methods that are existing are just focusing on measuring immediate results from adaptation options. So here we are looking at output type of results. We don't have clear methods that actually help us to assess the effectiveness of adaptation options. And that means even the kind of data we have, it's not even fit for purpose. Even then, when you're going back to even inform the NAPs and indices, because they will tend to be very short term. And again, if you look at even what is being assessed with the implementation of NAPs and indices, we are ending up at a similar situation. We've just launched the UNEP Adaptation Gap Report, where we were assessing what is countries reporting through their biennial transparency reports. And again, the picture is the same. We're just focusing on immediate results. So even as we move into AR7, there's an impetus to highlight some of the methods that different stakeholders can be able to use, not only to do impact and risk assessments, but also to evaluate how we are adapting to climate change, what is working, under what conditions. And in line with this, one of the key products that is going to be part of the working group 2 is the update of the technical guidelines for impact and adaptation. And essentially what these guidelines would be, it's a documentation of what different methods, approaches, models that can be used across the adaptation cycle. So it's doing the risk assessment, it's what type of methods you can use for your planning, implementation, but most importantly, also what type of methods you can use for monitoring, evaluation, and learning. One of the key agenda items for COP this year is hopefully getting to a point where we agree on what type of indicators we can use to assess progress in adaptation at a global level. But based even on the assessment of the experts, we are going to have indicators that don't have methodologies. So there's a very clear link between even what the AR7 is planning to do and how it even connects to ongoing policy conversations on under the UNFCCC. But then the call to action would be, and which is now what connects even to the discussion we're having today, is how can organizations such as the FAO, CGIAR use their convening power to be able to bring together scientists, practitioners, who can be able to document some of the methods to make sure that we are leveraging the experience that we already have to understand what are the opportunities and pitfalls with some of the methods that are already being used. The guidelines that are being updated now, the last version is from 1994. So they are so 1990s. They were just like static text that is based on PDF. We are at an era where we can have more dynamic presentation of the information to make sure that we can also continuously update it. But most importantly, also to make sure that the guidelines are fit for purpose. We have so many stakeholders that now are looking into mainstreaming adaptation. So we need methodologies that can be used by various stakeholders. The 1994 guidelines were purposefully designed for researchers, but we are moving into an era that even the private sector, they want to mainstream adaptation. So how can we make sure that the IPCC, as we move to action-oriented outputs, they are also speaking to these diverse stakeholders as opposed to just focusing on researchers? Thank you.
Brilliant. Brilliant. Thank you so much for that. I mean, and you mentioned the part of the negotiations that really is linked to us in the global goal on adaptation. We were also hoping to come out of here with at least an indication of some set of indicators of adaptation in agriculture and food systems, which was a bit of a missing piece when you look at the the NAPs when you look at the biennial transparency report. So that definitely is a gap that needs to be closed. And thank you for helping with the with closing that gap. So we come to you now. I mean, we've heard a lot about climate science. There are many gaps that still need to be closed, but at the same time, how can we make sure that the climate science, what we have now and what we're trying to in a way get as we head to AR7, is also reflective of or aligned with the realities of farmers on the ground? Because now, as we heard from Lucy, our constituency is much broader now. We're not just talking to a few scientists, we're really talking to our entire community for action-oriented kind of science. Over to you.
Thanks, Kaveh. And in the interest of time, I'll keep my intervention short. It's been really reassuring hearing this earlier speakers, because I think there are many common themes. And I'm going to focus on three things. Firstly, bridging the gap, and we may see different gaps from others. Secondly, around scale, and thirdly, on data. And I think in the data space, opportunities for farmers and researchers and policymakers to help each other. So I'm going to start on bridging the gaps. I don't need to tell this audience, bridging the gaps between science and farmers is critically important in lots of spaces, but particularly in the space of climate science. And we would feel that farmers' organizations are one of those stakeholders that can be part of that bridge. But we're very grateful for the IPCC for connecting its vice chairs to constituencies in the space. That's really a welcome development, alongside, a million thanks as ever to the FAO for the support it gives, particularly to developing countries. I think we see some gaps which perhaps have already been highlighted in the science. On soils in particular, critical to removals, alongside the climate sensitivity of different land uses, particularly under land use change. I think we're interested in the vulnerabilities of carbon stores and additional sequestration. Livestock, there's been a lot of talk about the importance of integration and interactions. How does that respond to climate? But also on sociocultural, economic, and economic implications. Scale, temporal and geographic. How to resolve the very short-term nature of that farmers, the pressure that farmers find themselves under, alongside weather versus climate. There must be a pathway to help farmers understand. Geographic. We need to make this relevant to farmers. So translating climate impacts or likely climate impacts into geographic scales that make sense to them. And then finally, on data, the space of data collection, whether it's for adaptation or mitigation progress, this is somewhere we can help each other. How do we make all this data that might be collected useful to farmers, as well as to those reporting, whether it's national governments or for supply chains? And as an opportunity here, as more technology is used in agriculture, how is that data made available, but in a fair and transparent way? And how do we couple that with farmers' own knowledge? So that feels like a good place to start. I had lots more to say, of course, but anyway, in the interest of time, and thank you very much.
Thank you so much, Cyrus. Thank you for bringing that perspective. And you sort of took us back to where the IPCC chair started us off. He said, yeah, we've got to close these gaps. We know that how to jump from AR6 to AR7. There's a lot more to be done, but we've got to make it action-oriented at the end of the day, whether it's for the farmers or the private sector, or of course the national governments. It has to be more action-oriented, and that's really one of the purposes of our collective work. I'm looking to you, Martial, to see, do we have a few minutes or are we run out of time? Or the owners of the pavilion? A few minutes. All right. Well, are there any burning questions and not statements, but questions before we do a final sort of 1 or 2 word round with all of our speakers? Yes, sir. Can you introduce yourself and give us your very fast question?
My name is Doma from Cambodia. I teach in a public university in my country. I would like to ask the question to Dr. Lucy that the ecosystem in my country impacted by fluctuation of hydrology flow and also it destroys seriously the food ecosystem in my country because of fluctuation of hydrology. We would like to conduct the solution that we think is that not science alone that can solve the problem, but also integration between the science and tradition of the people for saving the ecosystem, the food ecosystem. We would like to conduct several studies, scientific studies for publication. So do you have any capacity to support if we would like to produce the publication, several case study in my country? Thank you.
Okay, thank you very much. It's a big question, but you all get to have a couple of words, a few last words. I mean, it is about how can we make all of this useful at the end of the day to countries and to the different communities we're talking about. But the purpose also of this session was maybe for you to touch on, are there any gaping gaps that we need to close between AR6 and AR7? Yeah, and I think many of them have come out, but feel free in your last, 1 minute each to tell us what are the big gaps to close and how we can then close the gap, as it were, to our clientele. And Lucy, why don't you start us off?
Okay, thank you. And I think this is a very good question that also helps me respond to that. Because one important thing to note is that the IPCC does not produce its own research. It synthesizes what already exists. And whereas I work specifically in the agriculture sector, one of the strategies that we are using, especially focusing in areas that have historically been underrepresented, which of course in this case is Africa, is to see how we can form smaller coalitions within the region to synthesize the knowledge that we have. There's already some timeline that is allowed between now, I don't know when is the deadline for cutoff period for publications. And during this time, we can team up to do this kind of assessments and to produce publications that then get picked up in the synthesis for the AR7. This is definitely a strategy that needs to be worked out. Ourselves, as we work within the CGIAR, we are ready to support. We have a project that is funded by the Gates Foundation called Adaptation Insights. And through this project, we are focusing also on synthesizing the gray and peer-reviewed literature that already exists, and to make sure that we can have this published to be picked up by the AR7. We saw a very successful approach in the AR6. This was with the Global Adaptation Mapping Initiative, GAMI, where they took this approach where stakeholders were coming together to synthesize the knowledge they already know, and many of the publications that they produced were definitely captured in the AR6. So I think this is already a tested approach and has been effective. So I'll be happy to connect with you and see how we can take this forward. Thank you.
Perfect. Thank you so much, Lucy. Stefan, you've heard what we've talked about, and I think the collaboration that we've had, we pinpointed one area that needed more research in the science, that was extreme heat. There might be others that we should be picking up together as we head towards feeding into AR7, but your final thoughts.
Thank you. I'm sure there's many other areas, but I try to also relate to his question, if I may. I presented this result, which is the result of the of this report of the collaboration between the FAO and the WMO, and of course many experts contributed to it and synthesizing a lot of science of many people. But I think it's a good example that this all depends on each other. So it's not a question of agriculture only. It's not a question of climate science. It's not a question of hydrology, where I'm responsible for at WMO. And we see some sort of fragmentation also sometimes at national level. So it's really about, if you really want to make a difference to extreme heat and agricultural productivity, it's about really seeing this as a kind of a joint effort and this kind of systemic approaches. I think that's one of the key things, I believe.
Stefan, thank you so much. And that's, I guess, perfect series, because together we've been trying to get this issue into the conversation of the COPs for many years, and it's begun to make its way, but there's probably is a little way still to go.
I'd like to finish on communications, actually. Martial highlighted agriculture and land use is, I'm going to use his word, is the sector with greatest untapped potential. But many farmers feel like they're the enemies of the environment. If we really want positive, action-oriented practices, how do we resolve those two things? And just one sentence to finish, perhaps a challenge for science and research. The speed of change is beyond what farmers and many generations of farmers before them have experienced. How does science respond to this speed? Thanks.
Thank you so much. Martial, as our organizer, the last word goes to you.
No, just to help, to respond also to the question on the cutoff date, so we will have time, because I guess it will not be before 2027 for the assessment report. For the short-lived climate foresight, it will be mid-2026. So we are on the right timing to produce science and data, but we have to speed up. And just to, on a positive note, on curious to build on what you are saying, the IPCC FAO expert meeting that we will hold will be at FAO mid this year, first week of June, tentatively for the moment. And the idea is to have not only scientists in the room, but to bring the farmer together. And IPCC is really involved in that connection with all the stakeholders, the end user of the science, and the one that can help us to collect the data, because you are on the ground and you have plenty of data. So how we turn those data, also our climate data, and how those climate data really help the farmer on the ground. So this is what I wanted to add. And you have all the title, we need to transform agri-food system. So we have no other option. So thank you, Kevin.
Thank you. So a big round of applause to all the speakers and all the institutions who are kind enough to support us with this event today. And thank you for joining us, and good luck with the rest of your hot day.
Hot spot.